Up next, we're going to have Hassaan Idrees from Jacobs Engineering. And Hassaan's going to talk with us about energy for our water use. So let's give him a welcome.
Boy, Steve is a hard act to follow. Right. So, hi everyone, my name is Hassaan Idrees. I'm going to be speaking about energy for our water use. Everybody knows the kind of climate we've been facing in Colorado. We've all experienced the heat waves, the wildfires, the fast melting snowpacks, and now the fast depleting Colorado River. So it's everybody knows the kind of Colorado River difficulties that we're facing. It's the #1 most endangered river right now in the US, and it feeds 40 million people in the West, and a lot of our water and energy-driven economy is dependent on that. So if it dries up, it's a big deal for us in the Southwest and in Colorado. Every day we use more than 400 billion gallons of water. That's like 10 billion bathtubs. So that means a lot of energy is basically going into treating that water, delivering that water, and basically making sure that it gets to our homes. So the more energy we use, for example, we use 156 gallons per day per person in the US. That's like compared to 3 gallons per day per person in Mali, Africa. So you can see how much energy we're using and then how much energy goes into treatment of wastewater that again goes back into the system. So the more water we use, the more energy we consume. There's a lot of disparity in the US. More than 2 million people still have difficulty in accessing water. And a lot of them are Native Americans who also have difficulty in accessing electricity. And because of the fact that energy and water are so interrelated, a lot of their cyclical needs are not met. Here's a look at basically from the tap to toilet. So 7 terawatt hours are used in a year for water treatment. And basically, once you drain the toilets, there's like 30 terawatt hours. It's like more than 4 times that energy. So you can see the disparity of how much energy we're using, both in terms of treating water and wastewater. More than 40% of a town's bill goes into treating of the electrical bills. And more than 80% of the municipality's bill goes into motors and pumps and other electrical equipment. It's essential to understand the wastewater treatment process. It basically starts from the influent pump station, and there are like 4, 5, 6 other processes. Each has a lot of electrical and energy consumption, and it basically at the end goes into the creek after disinfection by ultraviolet rays. The EPA has given this kind of a roadmap to energy savings to utilities. It's a basic plan, do, check, act, holistic cycle, and they can follow that. And it's very easy in terms of they can tailor it to their own personal interest and their own personal energy usage. And for example, these are different tools. One of them is energy performance indicator. So how that helps is that you can find out exactly how much energy is being consumed at each and every end, every equipment, and that helps them. For example, they can upgrade to more efficient equipment. And if that happens, they're able to reduce their energy use. 3 energy considerations that are important at a plant, and that, of course, aside from the metering and sub-metering and energy use, the third one, which is often overlooked, is the renewable energy installations, how much you can capture the energy, and that doesn't have to be solar or wind. You can also use biogas, which we'll talk about in a minute. So, of course, upfront cost is the biggest monster, or the elephant. And aside from that, these utilities are really old, so they're kind of risk averse, and they have obsolete equipment, and it's kind of difficult for them to force into making a lot of these changes. Like everything else, we have these trade-offs in terms of, for example, if you increase the dry cleaning, which reduces the use of water, then you decrease the efficiency of plant. So then there's a lot of trade-offs we need to understand in terms of what kind of means which we're trying to implement at a water or wastewater plant. Now, this is a pretty complex cycle. So I'll give an example of the South Platte River Authority, which we have in Englewood here. And they're trying to use a lot of wastewater reuse, which helps in capturing a lot of energy right at the plant itself. So for a lot of population in the metro area in the Southwest, so it's helpful because we can capture that energy instead of just letting it go to waste. Leakages in water pipes is another big area. A lot of them are not really treated well. So one example was that they reduced the leakage from 54 to 29%, and that helped in reducing a lot of electric consumption as well. Submetering is another point where you can see where energy can be tracked, how at every point energy can be tracked, and then you can see the faults before they can actually occur, and it helps a lot of preventive maintenance. Moving on to, after submetering is of course biogas. Wastewater treatment plants have these anaerobic digesters, and they have these gases which are produced, and if it's not captured properly, if it's just flared off, it's just missed opportunity. And if you do use it, you can have a lot of uses for that, and that again helps reduce your energy consumption. Microgrids are not as often implemented in wastewater plants because they're pretty cost intensive. And again, these are pretty cash-strapped organizations we're talking about. But if they do go ahead with this one, it helps them make sure that they're very energy resilient, it secures their energy future, and it can help them prevent future outages because they're independent utility. So that's a lot of conclusions. Every problem in orange leads to a solution. But I'd like to put an example of the Denver Water Plan, which is like a big plan in terms of working with a lot of stakeholders, and they want to prevent a solution. They want to prevent some sort of an outcome which leads to dry water wells, which is something we don't want, because Colorado is having a lot of decrease in water energy, and basically we want to make sure that we avoid that. So thanks very much.